So, Patrick, what excitement we have. A huge announcement that you may have known something about, the rest of us didn't. 24th of October, um, 600,000 from UK research innovation. Really, it's about getting your cognitive function test into the NHS. What has happened?
Yes, there was basically there's two things going on. Number one, there's a tremendous focus on diagnosing those at risk of dementia earlier. And part of it, let's be a bit cynical about this, is none of the drugs have worked later in the disease process. So they start thinking, well, if we're going to have a success with the drugs, it's got to be earlier. So how do we find people earlier? So on the back of that, there's this big trial, the Readout trial. It's part of the blood biomarker challenge to find things that change in your blood that would predict that you're on the flight path for dementia. Now, the issue is that dementia of every kind, Alzheimer's, vascular, whatever it is, the essence of it is it's a decline in cognitive function. So to some extent, to validate the blood test, you need to have a cognitive function test, and also to diagnose in advance those at risk, you need a cognitive function test. So our cognitive function test is validated. In other words, 10 years ago or more now, actually, if somebody went to a memory clinic to have a proper cognitive function test, which measures certain functions, aspects of memory, executive function, and so on, we digitized it with permission, and we've run almost 500,000 tests now. So the need for this move in early diagnosis of those at risk, and also to validate blood tests, required a cognitive function test. That was the bid. 18 groups applied, and we're very delighted to say that we have won.
Amazing. The background, of course, is that the UK, like most other industrialized countries, is facing a massive problem with dementia, particularly Alzheimer's disease. UK Alzheimer's research are saying that the current cost is around about 25 billion. By 2050, they expect the cost to the UK to be about 47 billion. And imaging, am I right in thinking that imaging has been one of the key methods? There just isn't enough resource to be able to image people. So we need to move to other mechanisms for early detection, biomarkers, and obviously digital cognitive tests. So how's that look?
A couple of other things there. Number one, also dementia has become the number one killer. People don't realize that. It is the number one killer. It's the number one healthcare cost. And it's also overtaken weight gain as the number one fear. So it's very strong on the agenda. And you're quite right. You can be diagnosed with dementia or pre-dementia, which is called mild cognitive impairment, from a cognitive function test. So that you can do. But about 2/3 of dementia is Alzheimer's. And Alzheimer's is a very specific pathology that occurs to a central part of the brain, which requires a scan for its diagnosis. Now, actually, you could do those scans very early because you do see changes 30 years before a diagnosis, but of course it's very expensive. So you're quite right. What's the quick win they're saying? What's the one test that we should do to find out who's at risk in order to then do something about it?
So let's just backtrack. Why do we have such a dementia, particularly Alzheimer's disease epidemic? Why is it increasing at the rate it is?
Well, as you and I know, many of these diseases can only really be understood on a systems-based approach. So from my point of view, Alzheimer's dementia is just another organ being hit by the melange of metabolic syndrome, nutrient deficiency, anti-nutrient excesses, lack of positive lifestyles. And one very sort of simple analogy of this is that if you actually look at the 30 known risk factors for dementia, including things like cataracts, smoking, pollution, sugar, whatever you look at, and you simply ask 3 questions. One is, does this affect the structure of the brain? In other words, is it part of the actual structure of the brain, like omega-3 is a major part of the structure of the brain? Or is it affecting the function of the brain? So, for example, we all know about insulin resistance. And there's a real irony here because people who've eaten too much sugar and carbs end up insulin resistant and end up unable to get sugar into their brain. So they actually suffer from brain fog because they have no fuel for the brain, and the brain tells them, you need sugar. So you get this increase in sugar craving and brain fog. That's a function, but then you have to have utilization. So, for example, if you can't hear, or you can't see, or you don't exercise, or you don't learn new things, you only build the brain just like a muscle if you're exercising it. And as soon as you realize structure, function, utilization, every single risk factor falls into place. And I would say that Alzheimer's is just sort of the perfect storm, following in from heart disease, diabetes, weight gain, joint problems, and all that sort of stuff. So
But
it's not
it's all interrelated, isn't it? I mean,
it's
in
all
the
integrated.
integrative world, we've been using the term type 3 diabetes to
Yeah.
refer to this kind of degeneration for, I think, 15 years or more.
I
But that
think
hasn't really found its way into the public mindset, has it yet?
no, it hasn't. And funny enough, if you sort of step back and say, where is the evidence really, really, really strong? It's really, really, really strong for homocysteine, really, really strong for omega-3, and really, really strong for sugar.
So, so on that point,
Yeah.
Patrick, is homocysteine one of the biomarkers that is built into the readout project?
No, and I do not understand why. Professor David Smith, former Vice Dean of Oxford Medical School, world leading expert on homocysteine, published over 200 papers. It's clearly established as causative for Alzheimer's, not just a risk factor, but causative. He said, are you including homocysteine in your biomarkers? And the answer was no. So I don't understand why that is. And for those who've never heard of homocysteine, basically the simple way of saying it is that brain cells, or the membrane of the neuron, are made from omega-3, not only, but mainly DHA, omega-3 DHA, which is rich in oily fish and seafood and marine food, which has to attach to a thing called a phospholipid, which is also rich in marine food and eggs and pretty absent in a vegan diet. And the attaching is done by a process called methylation, which is dependent on B vitamins, especially B12, as well as B6 and folate greens. And if you don't have enough B12, you can't do this. And what's kind of emerging is a lot of people later in life malabsorb vitamin B12 to an extent. An example is, my wife and I were both in our 60s. She's younger. We eat the same food. If your homocysteine is above 10, your brain is shrinking. Homocysteine only goes up in the brain if you're not doing methylation, which is a function of your B vitamin status. You want to be at 7 ideally. Above 10, you need treatment. Above 11, it's very clear that there's extra brain shrinkage. So my level was 7 and her level was 15. She needed more B12. I only supplement 10 micrograms of B12. It's 5 times the RDA, and I'm absolutely fine. My homocysteine stays normal at 7. She needs to supplement 500 micrograms of B12. And approximately half of the population over 50 or 60 have a raised homocysteine. So yes, when we look at all these metabolic, diseases and sugar and all the rest of it, they have that in common. But because Alzheimer's really and dementia creeps in at a later age, I think it's one sort of extra, big, strong underline is homocysteine and the B vitamins. And what we now realize, and this is so obvious, if you don't have the B vitamins, you can't do methylation, your homocysteine is high, you can't bind the omega-3 into your brain. So omega-3 doesn't work. And similarly, if you have all the B vitamins in the world, but you don't have omega-3, there's no way you're going to build the neuronal membrane. It's a bit like, if you give a builder a hammer, do you get a house? No. If you give him a bag of nails, you get a house? No. If you give him a plank of wood, you get a house? No. And that's the omega-3, the phospholipids, and the B vitamins. But if you give...
Readout does have B vitamins in there. It has B6, B12. It also depends where you measure them, because I mean, with folate in particular, blood levels tell you very little. Red blood cell count gives you a much, or red erythrocyte folate gives you a much more accurate reading. Do you know much about what they're doing with readout around B vitamins?
I don't know enough. And serum B12, which is very readily available to all GPs, is reasonable. So, to include that and look at that is a good thing. But if you want to cut to the chase, you go straight to homocysteine, because what we know is if you give the B vitamins, you lower homocysteine. If you lower homocysteine, you stop the rate of, or massively reduce the rate of brain shrinkage. You stop the clinical signs of dementia, and you really slow down decline in memory over years. So it's the only thing that for which the evidence is causal. I'm sure we will get to causality with omega-3, and I'm sure we'll get to causality with sugar, but sugar is quite a hard thing to study. It's very hard to do randomized controlled trials on sugar. It's much easier on, omega-3 or B vitamins.
So, cognitive function test, extraordinary work that you've done with that. This is a pathway to see it integrated into the NHS triage system. There is another digital cognitive test being evaluated alongside it, or I gather they're not going to be put in competition. Does that mean there will be two tests out there? Tell us about what's happening with these two tests.
Yeah, I mean, possibly. We don't know the full details. We've been told it's not, exactly a competition. In a sense, what they're doing is running a whole lot of blood tests, and they're running two, digital cognitive tests to see how that, relates or predicts people with dementia. Obviously, a lot of these people won't have dementia, so you have to wait a while to see if they will get it. And there's another aspect of this too, which is the practicality of it. We are in the process, which will be greatly accelerated by this grant, of making a smartphone-friendly version of the cognitive function test, which is not as easy as you think, because the traditional one has, grids of objects you have to see. So it changes things a little bit. And also to make it available in any language, because the test itself is not language-based. You're matching things, but obviously the instructions are. And there are plenty of ethnic minorities in the UK who can't easily, read. So we want to create something that they can do. Because the other big problem is if you imagine a future where you have to go to your doctor and then they sit you down and then they run a test and all the rest of it, it's a hell of a burden. But if you can literally go on a link, on your phone, do a test, if you don't do well, then, go and see your doctor. And by the way, you can't cheat on this test. I mean, you can't do better by cheating. You can do worse because, I don't know, you're blind drunk or the cat jumped on your lap or something, but you can't do better.
But the project readout itself is really a research project, is it not? Do you envisage this being used as a mechanism to, if you like, validate biomarkers, so that ultimately they would use biomarkers rather than cognitive function tests? Or is this something that where you would see, even at the primary care level, the local GP saying, look, I think you should take this cognitive function test?
I think it's going to have to be at least, well, both, but definitely a cognitive function test. It's a bit like, if you're interested in blood pressure, you measure blood pressure. If you're interested in cognitive decline, you measure cognitive decline.
It's the empirical test, isn't it? I mean, that's
totally.
where the rubber meets the road.
It absolutely is. And, some would say, why not just do that? Because we have, by the way, now from hundreds of thousands of tests, we've established that the cognitive functions score is declining relatively linearly on average from the age of 18. In other words, a 30-year-old does worse than a 25-year-old and better than a 35-year-old. So the point is, you might not get into what's sort of considered the danger zone, just like blood sugar. I remember years ago when Professor Bonnie Spring came to the UK, and she argued that it wasn't just diabetes or you're normal. There was something in the middle, and she sort of laughed out of court. And so at the moment, we have this idea that everything's totally fine until you hit significant cognitive decline, which we call mild cognitive impairment, or really bad cognitive decline, which we call dementia. But actually, it's a sliding scale. It's happening all the time. So we've already established that. So it's going to be very fascinating to see what happens with blood tests, alongside this.
Well, we've also got the interaction with genetic tests, because obviously there has been some work and there's been a lot of talk about people with an ApoE4 profile. Have you ever linked ApoE4 status with your cognitive function test?
Well, actually, one of our developments in the next few months will be to introduce a gene polymorphism test looking at things like ApoE4. And ApoE4 is a very good one to unpack because, we hear these words, most people don't understand it. But if I unpack it, a gene are really the instructions, usually to make a protein, to make something. And we've all heard of LDL and HDL cholesterol, which slightly inaccurately, HDL is a good guy and LDL is the bad guy. LDL, the L stands for lipoprotein. Lipo is a fat, and basically the fat is being put on a trailer and carried around the body by apoprotein. How do we make the trailer? How do we make the transporter? And the answer is that's what the gene APO is for. It's for making apoprotein the trailer that carries fats. Now, if you happen to have ApoE4, you make less good trailers. They don't work so well. And if you inherit it from both of your parents, it's even worse. And it means you're not good at transporting fats. And for you, a very high fat diet would be a bad idea. And making sure you do get enough omega-3 would be a very good idea. And make sure you're getting the phospholipid, which is a kind of fat. In other words, getting the fats you absolutely need without a whole lot of extra, fats. So having these gene polymorphisms skews you in understanding a little bit more where your strengths and weaknesses are. But the thing that fascinated me, and I just put this out there as an example, is of course all the big studies, including readout, will be looking at ApoE status of people. And I've looked at almost every one and asked the question when a change is made. For example, the finger trial was a very, very good trial, multifactorial, helped people to change their diet, their social interactions, their intellectual stimulation, their exercise, doing all the right things, looked at ApoE4. The trial was successful. Was it more or less successful in those with ApoE4 than those not? Made no difference. Another study in the British Medical Journal, 29,000 people, those who had a bad diet and lifestyle compared to good had 11 times more risk for dementia. Did those with ApoE4 do better or worse? Made no difference. So, and the same is true with the genes that make you bad at methylation. It's called MTHFR, methyl tetrahydrofolate reductase. That's an enzyme made from a gene. If you happen to inherit the polymorphism, which is MTHFR677T, which means one parent, or TT means two parents, you are more likely to have a raised homocysteine. You are less good at doing this methylation thing. But once again, in the B vitamin trials, big trials, placebo, B vitamins, obviously they've measured the genetic polymorphisms, because in your control group and your treatment group, you have to have roughly the same number of males, females, smokers, and gene polymorphisms. Did it make any difference to the outcome? And the answer is no. So I conceive a lot of these predictive genes, and they're not the causative genes, because we should also mention them, but predictive genes, they're like a weak light, which in the darkness of our lousy diet and lifestyle do confer extra risk. But once you shine the strong light of good diet, maybe supplements, exercise, etc., you can't really see the effect.
But that's epigenetics as well, because these are modifiable risk factors. Let's talk about that a minute. So the ultimate aim would be to have a kind of triage system. There's a real possibility of looking at all of these factors, from where you perform in a cognitive function test, where you are with biomarkers, where you are with genetic polymorphisms, so that you could then essentially triage along a sort of traffic light basis, green, amber, red. A significant number of people caught early enough. This is presumably the intention. I mean, when we look at cancer, we're seeing some real data that is showing that people who have early detection with very targeted, personalized, individualized treatments do very, very well. When it comes to Alzheimer's, I mean, we're struggling a bit when we look at the toolkit of therapeutics, are we not? I mean, we keep coming back to your fantastic toolbox of B vitamins and omega-3. That's not in the mainstream toolbox.
Well,
so what's happening in that area? What benefit? And obviously there is presumably strong interest even within the NHS on lifestyle modification. That is recognized, is it not?
Well, I think there are two things here. Number one, obviously, if you can find out who's in the flight path for a disease and do something about it early, that's better. It's called prevention. I think right now prevention is slightly being hijacked to mean early drugs. And in my life, I always ask three-word question: what causes that? And our diseases are not caused by a deficiency of drugs, so you have to ask what causes that. That brings you into the zone of prevention. And here it gets really quite murky because in China, where they did an incredible meta analysis of randomized controlled trials, they concluded that lowering homocysteine with B vitamins, which is so simple and so easy and so cheap and so safe, was the most promising treatment. In the US, National Institute of Health, they did a similar type of study and they concluded that 22% of the population's risk was homocysteine, raised homocysteine, and 22% lack of seafood, omegas, and so on. So real quick wins. And then, it was a real shocker. For the third time in the UK, we had the Lancet Commission on Dementia Prevention. So this is a commission of experts on dementia prevention. And for the third time, we sent them all the evidence that they could possibly need. The evidence that was good enough for America and good enough for China on omega-3 and B vitamins. And they didn't even say anything about B vitamins. I mean, it just wasn't in there. So just like ignore it completely. And then on the omegas, they did a little dirty trick, really, which was in a section called Not Enough Evidence. They cited one study on omega-3, which had shown reduced brain shrinkage, reduced cognitive decline. So they weren't saying it was wrong. It was a good study. But by including one study, the implication was we can't do a meta-analysis because there's only one study. And presuming that these are intelligent people, if you go into PubMed, the Library of Sciences, right there on the front page, the work's been done for them, proper meta-analyses of randomized controlled trials showing massive reductions. I mean, they literally had to, click a button or read the leading Alzheimer's and dementia journal in the world, which you assume that they read. So how
Patrick, this is corruption, is it not? Let's talk.
it is.
It
I
is
think
corruption. It's what Bobby Kennedy is trying to deal with in the US.
yeah.
It's not science. It's politics and
It's
economics.
politics. And I think, unfortunately, in the Alzheimer's area, and this is why people are, very happy to talk about, hearing loss and cataracts and exercise and, eating well. But the issue is that the whole field are desperate for a drug. And we've got a slight cart before the horse situation now. So all this money is going into how do we find those early on who have a problem so that we can treat them. But there isn't a treatment. I mean, there is no drug treatment yet that has produced a clinically significant effect. And that means an effect that the person, their carer or their doctor or their family would notice. So 20 years ago, it says we will have a cure, and we are nowhere near a cure. And those big headlines we see in the paper of these anti-amyloid injections, a little bit like a vaccine. You inject antibodies that attack this thing called amyloid. They do reduce amyloid, but they don't actually produce a result. So the European Medicines Agency have not granted any license to these drugs. The UK agency, shockingly, in my opinion, did. But the agency, NICE, who tell the NHS what they should do, said they're not worth it. They don't work and they're too expensive.
Just explain that a bit, because I mean, a lot of people have had the amyloid view that, this is the primary problem. It's not the real target, is it not? Phosphorylated tau is much more significant, and there's a very strong link between what has happened in the cardiovascular disease field. I mean, homocysteine, let's face it. How many decades ago did we see homocysteine as an emerging risk factor? It's still they've blocked it all the way, and now they're doing it in Alzheimer's. So can you just take us through the amyloid plaques and the cardiovascular atherosclerotic plaques as well?
Yeah, well, absolutely. But the origin is quite interesting, because basically there are some people who get a genetically induced, very early onset Alzheimer's in their 50s, 60s. That's been known for a long time. In fact, Louise Alzheimer, who reported on the first case, this was a person who had really significant dementia decline in their 50s. So there was a hunt by gene sequencing as what's going on really for those people. And they found a gene mutation, which, by the way, also occurs in Down syndrome, which means you crank up the production of this peptide, which is like a protein, amyloid. So the gene is called APP, amyloid protein precursor gene. And if you inherit, the wrong variation of that, you have a very, very, very high risk of Alzheimer's. So they thought, fantastic, we found the thing that causes the disease, namely too much amyloid. Now, two things happened, and one thing very few people know is that they created these anti-amyloid injections. So you inject something that attacks amyloid and does successfully reduce it. And two trials tried that out on those very rare. There's only 500 families in the world who have the APP gene mutation. So it's very, very rare. They tried the anti-amyloid injection drug treatment on these people. And in one trial, they got worse. And in another trial, they made no difference. And in both trials, they had an awful lot of brain bleeding. And somehow that was fudged over and then thought, hey, we should give anti-amyloid to everyone. And if you step back in two directions, number one, and say, does amyloid actually cause this disease? Well, 30% of older people have got plaques, amyloid plaques in their brain without dementia. And 15% of those, with dementia don't have amyloid plaques. And in animal trials, mice induced amyloid plaques seem to behave quite normally. So it's sort of part of the pathology sometimes, but not always. But there's a much more important question, which seems to be being ignored. And that is, why would we be evolutionarily designed to produce a toxic peptide? Why do we make it? I mean, what's the point, really? Evolution will never have you produce something unless it has a function. And now we know that the function of amyloid primarily is two things. Number one, it stops bleeding. Now, anyone with a small amount of medical science will know that hemoglobin, red blood cells, hemoglobin, has in the middle of it iron, and iron is really toxic. It oxidizes. We're talking about rust. So the second the brain gets a bleed, it's incredibly dangerous. So we had to have a mechanism to immediately stop the bleed. And that's the function of amyloid. Now, just stepping to one side, we hear about vascular dementia and Alzheimer's and so on. You cannot do a brain scan on anyone with any kind of dementia and not find at least 1,000 points of injury. We call vascular dementia when you have a big bleed and suddenly your cognition is worse. And then there are mini strokes we hear about, which you may notice, but then there are mini strokes, which you don't even notice. And possibly if you're, heading a football or you're a boxer or whatever, you're having a lot of these mini bleeds. This would be so toxic to the brain. So amyloid is produced. Also, if you bleed into the brain, you can get pathogens, bacteria and viruses and so on. And we've heard about how herpes, shingles and, P. gingivalis, a bacteria in the mouth, if you have gum disease, can get into the brain and cause all sorts of havoc. So amyloid captures the pathogen. It stops the bleed. That's its function. In other words, it's the fireman. It's not the fire. So what happens if you rip out the amyloid? And the answer is you bleed. And, in my time in sort of medicine, we're at a point where something like a third of people given these drugs have bleeding or swelling. And in the pharma-funded trials, the death rate is about 1 in 200. This is outrageously high. Yep. So, but for some reason, the industry just cannot give up on amyloid. They are moving to p-tau, which I know you mentioned, which is certainly worth discussing.
Before you go there, just can you draw the parallel between what's going on with atherosclerotic plaques as well? Because that again is a healing response, is it not?
Well, yeah, I think that one of the things that sort of reminded me is that homocysteine, which goes up if you lack B vitamins and then can't do methylation, has two other knock-on effects. One is it raises p-tau, which we will talk about. But the other is homocysteine itself is a very powerful arterial toxin.
Yeah.
Now, when we look at studies, this isn't necessarily the right number, and you go, smokers have 4 times the risk of lung cancer to non-smokers. We call it the odds ratio in trials. I was looking at one trial where the odds ratio raised homocysteine 10 times more risk of dementia, but 17 times more risk of cerebrovascular disease affecting blood vessels. So basically, homocysteine is a massive blood vessel toxin. So now you start to find that many of the same things that we look at for heart disease, sugar, omega-3, B vitamins, etc., are also for the brain. And in fact, I think it was Hippocrates who said something to the effect of what's good for the heart is good for the brain.
Yeah, exactly. Okay, take us into the p-tau. P-tau is now
Yeah.
viewed as much more the target. What's the background there, also from an evolutionary perspective?
Well, I think there are two. You can see in people with dementia amyloid plaques. Not in everybody. I know everyone who has them has dementia. So it's
Or
not
you can have them and not have dementia.
exactly. So it's not consistent, but it's interesting. Let's say it's part of the pathology. A little stronger than that is there is a protein called tau, TAU, and it can get messed up and becomes what's called phosphorylated or p-tau. And what that does is it starts to tangle all the nerve connections. So you get what are called neurofibrillary tangles. And generally, the presence of tangles and the presence of p-tau is much more consistent in people with dementia. You ask a really good question that I don't know the answer to. Why are we evolutionarily designed to produce p-tau? Well, I don't know the answer to that question, but what I do know is that if your homocysteine goes up, so it could be that we're not designed to.
Well, exactly. Maybe it's our environment now never
Exactly.
intended
Yeah.
p-tau to be
Yeah.
formed. Yeah.
Exactly. So if your homocysteine goes up, it has 2 direct effects. One is it inhibits the enzyme that would normally clear this toxin from the brain, and it promotes an enzyme that makes it. So we know there is this direct association: lower homocysteine, lower p-tau, raise homocysteine, raise p-tau. But of course, it's not patentable, is it?
Yeah. Yeah. So, from a perspective of managing homocysteine, managing risk factors that contribute to the formation of amyloid plaques and p-tau, there's also this body of evidence that suggests that the lifestyles of the 21st century, particularly spending a lot of time sitting, carrying more weight than we should, also have profound effects. Can you just take us through how beneficial? A lot of people see lifestyle modification as a pretty poor cousin to a drug. At the moment, we've got a
Yeah.
pretty empty toolbox. How, and obviously,
Well,
we've all, Dale Bredesen's work has shown that you might need to do 36 things or 50 things or 100 things. Where are we with the science of lifestyle modification
okay.
in terms of creating, real world changes in people's risk?
Okay. So I can illustrate this terribly easily with omega-3 and homocysteine. So the first thing, Dale's model of 36 holes in the roof is good, but what you've got to know is what are the most common holes.
Yeah.
You know, what's
And for you in particular, that individual, because it'll be different for different individuals.
absolutely. And when the NIH in America said that homocysteine attributes 22% of the population's risk for Alzheimer's, that's 22%, because half of the population, roughly over 50 or 60, have raised homocysteine and half don't. So what I'm trying to say there is if you've got raised homocysteine, which means above 10, it increases your risk by 40%, but half of people don't have it. So the population's risk is only 20%. So it's already a very, very big number. And similarly, but slightly downscaled from that, is omega-3. Probably the next is sugar, which is harder to measure. Probably the next after that is the phenomenal role of antioxidants, polyphenols, and so on. Because if you're making energy in the brain, which makes a ton of energy, it's the most energy expensive organ of the body, you're making a ton of oxidants. So I call those the four horsemen of the mental health apocalypse: your brain fats, your B vitamins, the sugar, and the antioxidants. And I think that if you're bad, I mean, give you an example, and there's vitamin D is fascinating as well, but there was a very nice study, and they looked at people's vitamin D, homocysteine, and omega-3 level. And just from the statistics, they found that if the homocysteine was above 8, their risk for dementia was increased. If their vitamin D was below what we would call in the UK 50 nanomoles per liter, their risk was increased. And if their omega-3 index, which is what we measure, we have a home test kit that measures all of this, it was above 5% actually, or below 5% increased risk. So then ask the question is, what's the difference between a person who has raised homocysteine above 8, low vitamin D below 50, and low omega-3 index 5%? And the answer was 4.6 times the risk of dementia. So, this is getting to be big numbers. And the other thing that's really important in all of this, because then, of course, you add on exercise, you add on,
Just on that point, exercise, is the mechanism all related to just reducing the risk of insulin resistance, or are there other mechanisms as well?
No, it's very, very simple. If you do no exercise, you don't build muscle. In fact, your muscles will atrophy. And if you do no exercise for the brain, you won't build your brain. So you need to literally stimulate the brain. Now, physical exercise does both, but especially any exercise that might require, balance, coordination, etc. So running on a treadmill will be less effective than, hill walking up craggy hills, where your whole system is having to work out how to balance, you're using different muscles and all that sort of thing. But on top of that, of course, is when you exercise, what happens is you're stimulating circulation. So now you've got blood flow and you've got nutrients. One of the things that's emerging, quite strongly is, to some extent, exercise, having high blood pressure is bad. Exercise raises your blood pressure. So surely it's bad to exercise, right?
And it produces more oxidants and free radicals.
Yeah, exactly. So exercise is stressful.
Yeah.
But it turns out this process of putting yourself into some level of stress, in this case, physical stress,
Adaptive stress, yeah.
You recover. Same thing with if you go in a sauna and you're really hot, and then you jump in a plunge pool and you're really cold. This adaptive stress is fantastic. Same thing with intermittent fasting. Some days you don't eat, other days you do eat. So we're learning that we build resilience in that way. And in just the same way that to build a muscle, you have to tear a muscle through exercise, and then you build it. You've got to challenge your brain. And the most effective level of challenge is sort of on the edge of failure. Yeah. So, for example, when I hit 65, I decided I'm going to learn how to paraglide. And ultimately, jumping off a cliff, is quite a stressful experience. And, the motive to get it together is kind of good. And I've finished all the practicals now. I've just come back from the Alps, where I was doing 30-kilometer cross-country thermaling up to cloud base and all the rest of it. You're very stimulated. Your mind is very focused. Your body is having to react. It really is a sensory stimulation. And now I've got to sit a meteorology, air law, and aerodynamics exam.
Fantastic.
Yeah, many people, when they're younger, they think, yeah, that's great. I go to university, I learn new things, etc. And then you hear someone doing that in their 60s, you think you must be a nutter. But no, why do we have this culture where when you retire at 65, and I am an old age pensioner, I do get a pension, you stop learning. And what happens if you stop exercising is your muscles degenerate. And we know that older people especially need to exercise and build muscle and maintain muscle strength more. It's even more important when you're older than when you're younger. So that's also part of it. But if you are going to stimulate your mind, you need, the hammer, the nails, the wood. You need the nutrients and you need
100%.
fuel supply. Put it all together and it's an absolute winner. And the reason why I've focused the last several years on this is because I do believe that, Alzheimer's is preventable for 99% of people. Namely, there's only 1% or less than 1% who have these causative genes.
Well, maybe we will see paragliding entered into one of the modifiable risk factors if you are or you're not. Patrick, to finish off, I'm fascinated by the linkage between getting your cognitive function test in its smartphone multilingual format into readout and then potentially into the NHS. Now, everyone's got a pretty strong survival instinct. It's not the fact that it came from an environment where cognitive function tests were so strongly linked to your four horsemen, your B vitamin, omega-3 protocols. Don't you think it's just a matter of time before there's a kind of grassroots movement, a sort of a bottom-up push to get this stuff being taken seriously, and with that, obviously, homocysteine being regarded as a key biomarker? Could it come bottom up rather than top down?
I think that's definitely the case. And already GPs can prescribe, we say prescribe cognition, use the cognitive function test, put their patient base of their own volition through this process. Because basically what happens for the doctor is they send a link to all their patients, which they can do. They don't need any permission to do that. It's those texts, those annoying texts that you receive. I've just had my sixth for having a flu jab, And, people don't understand that if you take a lot of vitamin C, it's really not a problem, if you know what to do when you get
Vitamin D and zinc
the rest of it. But the point is that any GP can do that. And now the person can themselves, without having to go to the priest, without having to go to the church, find out what their cognitive function is, find out what their risk factors are, and then get guided to make changes. And that's a very important point, because part of this whole grant is digital cognitive assessments that can be done directly by people. So now we are in the digital age and the AI age, for better or worse. We are moving into the age where it's about behavior change on a massive scale across digital platforms. It's going to be much less, going to see one person. Not that I don't think that's a fantastic thing to do. It's going to be more about how do we effect a change. And the amazing thing about the digital age that we are in is it does sort of cut out the middleman.
Yeah,
You go straight to people.
it's very empowering. So just to finish off, people don't need to wait for the smartphone version. Your web-based version is still around. You got 500,000 people have already used it. Can you just give our listeners who may be concerned about their own health or those of their loved ones, their parents or whatever, where do people go? Food for the Brain website, etc. Thank you, Patrick.
Foodforthebrain.org, and you'll see a big button that says take the test. So click the button, take the test. You'll spend 15 minutes or so doing an interactive cognitive test. At the end of it, you'll fill in a questionnaire, and at the end of that, it will both say where your cognitive function is right now. So it's like a measure, like your blood pressure, where you are right now, and it will show you your potential future risk based on what you're doing. So if you're doing everything wrong and you smoke and you don't exercise, you eat loads of sugar and no omega-3s and so on, then your risk is 100%. And if you're doing everything right, your risk is 0. And then it shows you what's driving your risk the most and what the quick wins are. And all of that is free. And please, if a little bit of your brain says, "Oh, I don't want to know," think about that, because you would say that if you think there's nothing you can do about it. And what you're now learning is there is absolutely something that you can do about it. So all you need to do, and tell everyone especially over 40, but really anyone can do this, go to foodforthebrain.org and do the test. If you want to understand more, I have written a book, which is called Alzheimer's Prevention is the Cure, which is available from Food for the Brain, which unpacks the whole thing. It will empower you. And in really a very small amount of time, you will learn and experience what it's like. Because if you get everything together, your brain literally starts to sing.
And in terms of homocysteine test and the omega-3 test, that's all available as well by Food for the Brain. Yeah.
Yes, there's one kit, and it's called the Drift test, 5 in 1, and you'll see it on the website under tests, and it measures your homocysteine. So you buy this kit, it comes to you in the post. It's available everywhere: the US, Canada, EU, UK, Japan, Australia. You get the kit. Um, I'll tell you a little secret thing here, but the moment you prick your finger, you need a drop of blood for each test, and you drop it onto the card, put it in the envelope, send it off, get your results. So it's a doable thing. We're trying to keep the cost down. It's about, I think it's £225, something like that. But at the moment, we are close to finishing test driving a thing, a bit like the CGM, those things you see that people slap on their arm. We've got something that you slap on your arm, it collects the blood, right? There's no
Right.
pain,
Yeah. Yeah.
totally painless. You can do it on a child.
Yeah.
And then you get a little vial of blood, which you then drop onto the card, and it's foolproof. Every squeeze is a drop, and then you send it back. So I hope by early in January, we will have a pain-free method of doing this test.
People with needle phobia, and there's quite a few around. That's excellent.
Yeah,
Yeah.
I think that'll be a big breakthrough. Yeah.
Patrick, fantastic. Congratulations on the grant. This is a real game changer, and it's also an indication of your perseverance in this area. You've got a huge win. The future is looking brighter, but please, people can get involved today. They don't have to wait for tomorrow.
Thank you so much for all your help in spreading the word. It makes such a difference.
Thank you so much, Patrick.